Siyanamukela ohlelweni lwe-Ithala Edu platform enilethulelwa ngezilokotho ezinhle Ithala kanye ne-GoDigitalSA Foundation. Thamelani izifundo ze-mathematics, i-accounting, isiZulu ulimi lwasekhaya, isiNgisi, i-FAL, i-physical science, i-geography, ezobuchwepheshe, i-computer applications technology kanye namaklasi e-learner wellness okungukuzilolonga ngokomqondo kanye nomzimba. Lezi zifundo zethulwa nsuku zonke kusukela ngoMsombuluko kuya ngoLwesihlanu kuqala ngehora lesi-4 kuya kwelesihlanu u-4 kuya ku-5 ntambama nangoMgqibelo kusukela ligamanxe ihora lesi-8 8:30 kuze kugamanxe ihora lokuqala emini 1:30. Zithameleni futhi lezi zifundo emsakazweni Ukhozi FM njalo ngoLwesine kusukela ngo-9 kuya ku-10 ebusuku. Ningangena ekhasini lethu lika-Facebook elithi GoDigitalSA_movement noma kwi-YouTube uthi GoDigitalSA Foundation. Siyethemba nizolijabulela lolu hlelo oluhlose ukunifundisa futhi lulekelele kulokho enikufunda ezikoleni zenu. Luthokozeleni-ke lolu hlelo nimeme nabo bonke abanye abafundi bebanga le-12 grade 12 ukuze nabo bazuze kulo futhi nonke nicijeleke ukuphumelela kwizivivinyo zenu zokuphela konyaka.
Sanibonani bafundi, sesiphinde sahlangana futhi for physical sciences. Saku paper 2 chemistry. Sesenze i-rate of reactions, senze ama-chemical equilibrium. Namhlanje sikhuluma ngama-acid and bases. So khuluma ngawo namhlanje and next week futhi soka sisiqedela le topic ama-acid and bases. Right. What is an acid? What is a base? Siyaziyo ukuthi kunama-theory awu-2 azama ukudefine ama-acid, what is an acid and what is a base. The first theory, it is Arrhenius. The Arrhenius theory. The first theory, Arrhenius. We define acid as acid is a substance that will ionize in water to produce hydrogen ion. An acid, a substance that ionizes, in water, to produce hydrogen ions. Noma ungakhuluma ngama hydronium ions, it's fine. The acid leyo according to Arrhenius. Then Arrhenius phinde define a base as a substance that will dissociate. In water again. A substance that dissociate in water to produce hydroxide ion. So those are the two definitions according to Arrhenius. The first one is substance as an acid is a substance that ionizes in water to produce hydrogen ions, and a base is a substance that dissociates in water to produce hydroxide ions. That is the first theory. The second theory is a theory of Lowry-Brønsted. Now we have Lowry-Brønsted theory. Lowry-Brønsted theory. Now, Lowry-Brønsted theory says that an acid is a proton donor. It is a proton donor, while a base is a proton acceptor. It is a proton acceptor. All right. Now, a proton acceptor, masikhuluma nge-proton asisho ukuthi proton ile izothathwa from a nucleus of the atom, and then it is given away. Kodwa nge-proton sikhuluma nge-hydrogen atom. I-hydrogen atom ine-proton eyodwa ne-electron eyodwa. So when it becomes an ion, kusho ukuthi le atom ye-hydrogen has lost i-electron, so kusele i-proton. So masikhuluma nge-proton donor kahle kahle sikhuluma nge-hydrogen ion. Sibiza nge-proton ngoba the only thing left kuyona it's a proton. Though akhona ama-neutrons vele asiwa-counting ngoba a neutral one. So sikhuluma nge-charge of the atom, that is a proton. Kahle sikhuluma nge-H plus. I-proton sikhuluma ngayo is a H plus, like an atom of ion of hydrogen that has lost an electron. Right. Now, lama theories out to azosiza in terms of understanding a concept yama acids and bases. Right. Now, like the first one, a dealer ne Arrhenius, with Arrhenius, saying that an acid will be a substance that will ionize in water to produce a hydrogen ion. So, if it is ionizing in water, so there is a situation where an acid, because it will ionize in water, it can ionize completely. Some acid will ionize completely, and other acids, they will ionize partially. But just half of it will be ionizing. Now, the acid that ionizes completely, it's said to be what? A strong acid. So a strong acid is an acid that ionizes completely in water to produce what? A high concentration. Right, a high concentration of hydrogen ion. And an acid that does not ionize completely, or an acid that ionizes partially, that one will be what? A weak acid. So a weak acid is an acid that will ionize partially in water to produce a low concentration of hydrogen ion. All right. Sesiyabona ukuthi masikhuluma nge-acid, sikhuluma nge-substance, nge-substance izo-ionizer in water and to give you what? Hydrogen ion. For a base, it's a substance that will dissociate in water to produce a hydroxide ion. Necessity. Mawukuthi leyo acid le izo-ionizer completely, sibizwa ngani nge-strong acid. Le izo-ionizer partially sibizwa nge-weak acid. Lokhu kufana ne-base. Ne-base is about the same thing. The base that will dissociate partially will be what? Will be a strong base. The base dissociate partially, that will be a weak base, and the base that will dissociate fully or completely, that will be what? A strong base. So in terms of base, the base that dissociates completely, if it dissociates completely, then leyo base leyo sibiza nge strong base. Lokhu awazi ukushintsha, it's the nature of the base. Right? Leyo substance leyo bizwa nge strong base only because it can dissociate completely. Then the other base is dissociate partially. Right? The base that dissociates partially, that one we call it a weak base. We call it a weak base. So from its definition, Arrhenius, siyakwazi ukuthola what is a strong base, what is a strong acid, a weak base, and a weak acid. Right. Then I started a definition called Lowry-Brønsted. Lowry-Brønsted. With Lowry-Brønsted, ukhuluma proton donor. Njengoba sichazile earlier ukuthi proton is the H+. Low H+ uzorelease substance. Then we say it's a proton donor. Now, if sikhuluma proton donor sithini, let's say HCl, for example, as an acid. Ngoba i-acid kusho ukuthi lena izoba i-proton donor. Proton donor kusho ukuthi nifanele sibe able ukubhala i-ionization reaction. HCl uzoba OH+, siyabe izorelease OH+, iphinde izirelease no Cl-, ngoba i-ionization le HCl as unikezwe khona. Then for another acid, mhlambe sikhuluma H2SO4, lena ma-ionizer izosinika OH+ plus SO4 2-. Then mase sibalansise equation OH abawu-2 ngala sifaka no-2 ngala. Kusho ukuthini le acid yokuqala HCl can only produce ingakhipha OH owodwa H+, 1 proton, let's say that. HCl ungakhipha just i-proton eyodwa OH+. Then kanti H2SO4 wona ungakhipha ama-hydrogen awu-2, hydrogen ion awu-2. So any acid ezokhipha i-hydrogen eyodwa ibiza ngani nge-monoprotic acid. So HCl is a monoprotic acid. Monoprotic acid. A monoprotic acid is that acid that will can only release one proton. Ngoba Lowry-Brønsted definition uthi i-acid is a proton donor. So mangakwazi ukhipha nje i-proton eyodwa, then leyo acid leyo it is called a monoprotic acid. Bese sibuka H2SO4. U-H2SO4 ungakhipha ama-hydrogen ion awu-2. So that one will be called a diprotic acid. A diprotic acid is the acid that can release 2 hydrogen ion. Lokhu kuzokusiza kwi-topic elandelayo in terms of calculating concentration. So into soyibuka ngala sothi i-number of moles ka-HCl izofana ne-number of moles ka-H+ ezoba ekhishwe lo HCl as a proton donor. Right? Then for H2SO4, makune 1 mole of H2SO4 izosikhiphela 2 moles of H+. Right? That's why H2SO4 ibizwa nge-diprotic. Siyakwazi vele ukuthi di hambisana no-2 and mono is for 1. Right? Just to refresh our mind for few things. Masikhuluma nge-strong acid, a weak acid. Lokhu siyakwazi kuthatha from Arrhenius, or from Arrhenius uthi acid it will ionize to produce a hydrogen ion. So if it ionizes completely, then leyo acid leyo it's a strong acid. If it ionizes partially, then leyo acid is a weak acid. For the base is the same thing. A base is a substance that will dissociate in water to produce hydroxide ions. So if it dissociates completely, then leo base is a strong base. If it dissociates partially, then that base is a weak base. Right? Just to refresh your mind, to give you a list of acid that we can qualify as a strong acid or weak acid, strong base or weak base. Right? Just a few common acids and their strength. Common acids. Lama acid ajwayelekile, common acids as well as their strength. The first one, HCl. HCl is a strong acid. HCl is a strong acid. Then we have H2SO4. That is a sulfuric acid. It's also a strong acid. HNO3, nitric acid. It's also what? A strong acid. Wonke lama acid are strong ngoba they can ionize completely, right? They can ionize completely. Mese kuba khona ne HBr and HI. Any hydrogen halide, right? Except fluorine, but hydrogen hamba ne halogen njenge chlorine noma bromine noma iodine vaskiphela is strong vaskiphela is strong acid ngaphandle kwe HF. Remember ufluorine une electronegativity enkulu, so ionizeki kalula ku HBr, so ku HF, so HF will be a weak acid. So HBr is strong acid now. Then HI also a strong acid. Right? This is just a few acids as well as a common acid. They are strong acid. HCl, H2SO4, HNO3, HBr, HI. Just that, a few. There are many, but we just mention those few. Now let's look at acid are weak, the common ones. As say HF. This one is weak. It's a weak acid. With HF, hydrogen fluoride, right? It's a weak acid. Mesesibane acetic acid or ethanoic acid, CH3COOH, right? Acetic acid, it's a weak acid, right? Then we can also have a carbonic acid, H2CO3. Now it's a weak, also a weak acid. So just an example, Conano H3PO4 now as a weak acid, right? Kupenda kube ne oxalic acid njengoba ngithe, so just sonika just a few, right? You can easily get your information in terms of the list of strong acid and the list of weak acid. Into fanele uyazi ukuthi ini a strong acid. How do you define a strong acid? Sibuka nje Arrhenius, definition ka Arrhenius bese sithi it ionizes completely, seku strong lo. Masikuthi ionizes partially, then that becomes a weak acid. For the common bases, ngoba fanele niwazi common bases. Common bases, right? Most of the strong bases are metal hydroxide. Most of common bases are strong metal hydroxide, and sulfur, sodium hydroxide. Then we have potassium hydroxide, lithium hydroxide. Bonke lama bases lawa are strong base. So wonke lawa are strong base. Why city a strong base in Goba, they dissociate completely, right, to produce a high concentration of hydroxide ion, calcium OH2. Also, nioin is strong, right? Then a list of weak bases. This is your NH3, ammonia. Ammonia, it is a weak base. Ammonia is a weak base. We can also have the sodium bicarbonate. Now it is a weak base. We can also have what? Ammonium hydroxide. Ammonium hydroxide, also a weak base. It's just a list. Just a list of those acid and bases. Anything fanele siyazi makuthi acid noma base is a strong acid akushinji in terms of concentration or in terms of dilution. So ungaba ne strong acid ibe concentrated, noma strong acid ibe dilute. Ungaba ne weak acid ibe concentrated, noma weak base or noma weak acid ibe dilute. Ukuba concentrated or dilute akuhambisani ne-nature ye-acid or a base, kuhambisana nokuthi how many moles you have per unit volume, kuhambisana ne-volume yamanzi. Remember, Arrhenius, stay you dissolve it in water. So if you have more particles per unit volume of the solvent, then soti sine concentrated acid. So it can be a concentrated strong acid or a concentrated weak acid. So a concentration I have the nature. The nature of the acid or a base being strong or weak, lokhu kuhambisana nokuthi i-acid iya-ionizer completely, normally your base iya-dissociate completely. Right. Into efanele uyazi, it's to how to write ionization reaction. Ionization reaction, like for the acid, so timono HCl, for example, ionization reaction ya ukipela H plus, no bani, no Cl minus. Lana si ignora o amanzi, but you can also add water, right? Ngati HCl that react with what? H2O. Lokhu zosinika H3O plus what? Plus Cl minus. Ingakho by definition, by Arrhenius kuvele kuthiwa the acid is a substance that will ionize to produce what? H3O plus. Kiyafana, noma ungakhuluma nge-H3O plus, noma ukhuluma nge-H plus into eyodwa. Because that H plus vele awuhlala emanzini water, it always try to bond. It doesn't appear as free in water. So there's a bonder when molecule available. So you have H3O plus. This is a way of writing what it is ionization reaction. Stesa kuluma nge H2SO4. Now, by definition, H2SO4 is also an acid that will ionize completely. Now, if it ionizes, Lowry Brønsted kuthiwa it is a proton donor. A proton kusho ukuthi eyodwa. Kusho ukuthi before ikhiphe lama hydrogen awu-2 kuhamba nge-process. I-process yokuqala izokhipha u-hydrogen owodwa. Then you have H plus what? SO4 minus. Right, this is the first step of the ionization. Then kuzolandela the next step ezothatha lo HSO4 minus vele a release lo H wesibili. Then you have lo H waseqaleni plus the other H, then sino SO4 2 minus. Then egcineni singathi uthi H2SO4 uskiphela o2H plus what? Plus SO4 2 minus. And sithe ngoba le acid ukiphela ama hydrogen awu-2, then ibizwa nge diprotic. Ibizwa nge diprotic acid. So we have to be able to write a ionization reaction. Then siya understand futhi ukuthi makuno 2H plus i-concentration or H plus inkulu kune concentration ka H2SO4. It's twice actually. It's twice the concentration ka H2SO4. Right. Now this is how to write the ionization reaction yama acids. Right? The other one can be because lana strong acid as puge makune weak acids. Weak acids such as the acetic acid. The acetic acid CH3 COOH. This one is a weak acid. Sibizange weak acid ngoba it ionizes partially. So in that case, multi ionizer so bano CH3 COO then kuno minus ngoba it's a proton donor. Lo H usuhambile se usele H plus ngala. Right, that is the ionization reaction for ama acids. ukhiphela njalo lo H plus. Makunamanzi obviously lo H plus uzobonda ne H2O, because now soba no H2O plus H plus. Yabo kuzofomeka lento sibiza nge dative covalent bond. I-dative covalent bond lo kuzokunika H3O plus, right? Because by definition sithi acid iso-ionize emanzini and it will give us what? H3O plus. Then ionization for a base, dissociation for the base. The first base ngakhuluma ngayo is NaOH. Lena ma dissociator, then we can say lokhu kuzosinika sodium plus and then plus OH minus. That is the dissociation reaction esinayo. NaOH ya dissociator into Na plus sodium ion and hydroxide ion. Ilo OH minus wenza ukuthi solution ibe basic, ngoba by definition vele Arrhenius uthi it's a substance that will dissociate in order to give you what? OH minus. Kungenzeka ube ne calcium hydroxide, for example. Calcium hydroxide. This one zokunika a calcium O2 plus. Calcium 2 plus. Then sibe no OH minus about 2. Right? Again, here's keeper ama hydroxide O2. So a concentration ga calcium hydroxide is half a concentration ga OH minus. This is what we mean by a dissociation reaction, noma ionization reaction. So kuluma nge ionization reaction masikuluma starta acid, then siyahlukanisa in terms of ama ions, then that becomes what? A ionization reaction. Right. Now let's take one more example here. The first one, it's H2O or reactant HCl, right? In this case, ngoba HCl, it is an acid. An acid is a proton donor. So to keep a low H uzengala. So no H3O plus what? Plus Cl minus. Right. Now, asibugele reaction. HCl is a proton donor. Ngoba ethylene upenduga or Cl minus. So it means what? HCl has lost Leo proton Leo, that is the hydrogen ion. Right. H2O. The H2O here, it is H2O, ama hydrogen out ne oxygen yoto. After a reaction, segu H3O plus. So it means what? H2O has gained a proton, that is the hydrogen ion. So no H3O plus. It simply means that H2O is what? It is a base, ngoba. It is a proton acceptor. So this one here is amanzi. Amanzi in this case will be a base. Then HCl will be an acid. And we are going to define what is an acid and what is a base. Right. Now, another example. We have H2O plus NH3. Now, this one is osniga NH4 plus OH minus. OH minus. Asibugele reaction for H2O gal. Masisa ngoma product seku OH minus. So ngala sinama hydrogen out ne oxygen yoto. After a reaction se sele ne hydrogen yoto. Kushokuthi amanzi lawa H2O it has donated a proton. And says a proton donor, it's what? It is an acid. So kule reaction amanzi act as a acid. Asibuke NH3 ammonia. On the ammonia side, right, ukala NH3 nitrogen eyodwa ama-hydrogen awu-3. After reaction sesino NH4, so ama-hydrogen awu-4. This simply means that ammonia has accepted a proton. So any substance that accepts a proton is called what? It's called a base. It's called a base. Now, kasi siyobuke lama reactions awu-2. Yokuqala kunamanzi H2O, a reactor no HCl. And in this case, when we look at H2O, a base. HCl is an acid. Then we second reaction, H2O food, the same as the one esinayo la pezu. A reactor no NH3. Then ngokwe reaction, H2O has lost a hydrogen ion, so it makes it to be what? An acid, right? From the common, the list of common acid and common base, HCl. We had an HCl as an acid, and we said the HCl is a strong acid because it ionizes completely. It was part of the acid. Then NH3 is also what? It is a base, a weak base, because it dissociates partially. So we have that one. Inkinga ibala ku H2O. Ngala it acts as a base. Kotwalana it acts as an acid. This simply means that H2O can act as an acid or can act as a base. A substance that can act as an acid or a base is called what? An ampholyte. Ampholyte. So an ampholyte is simply a substance that can act as an acid or a base. Now, lana amanzi acted as a base ngoba be react an acid. This one is a non-acid, HCl. Ingako amanzi act as a base. Lana act an a base, vel NH3 cells uti a base. That's why amanzi act as an acid. So ampholyte, it will change always. My react an a base, it act as an acid. My react as an acid, it act as a base. Right. From the same equation, I hope you understand the concept, ampholyte. Now, let's look at another reaction, or this one, concept. So, H2O, or reactor, no NH3, again. Lana says, NH4 plus what? OH minus. A reaction. So from the previous example, we said this will be the acid and NH3 is the base. What if we look at this reaction as a reversible reaction? Remember, simonoguti H2O is an acid ngoba besibuga a product. Ngoba kuma reactant ukala ngama hydrogen awu-2 ne oxygen eyodwa, then uma product sekusele hydrogen eyodwa. In that case, we concluded that H2O has lost or has donated the hydrogen. And by definition, we say that an acid is a proton donor. So because amanzi donated hydrogen, then it is an acid. Then Sbugo NH3. How did we find that NH3 is a base? By looking at the product. Skanga hydrogen out-3 nitrogen after a reaction, says nama hydrogen out-4 and 1 nitrogen. In that case, ammonia has received a hydrogen, and any hydrogen or a proton acceptor is called a base. Asibuge ngokutile reaction, it's a reverse reaction. What if it is a reverse reaction? What if it is a reverse reaction? If it's a reverse reaction, OH no NH4 baso reactor, baskipelo H2 no NH3. Right. Now, if we look at that one, this is NH4 before the reaction. Lo NH4 uzopenduga NH3. In that case, that NH4 has lost. Ngoba bekuna ma hydrogen out 4 sekusela 3. So it means NH4S has lost. Any substance that loses a proton siyibiza ngani? Siyibiza nge-acid. So that one acts as an acid. Then sino OH, sine oxygen eyodwa ne hydrogen eyodwa. After a reaction, lokhu kuphenduka bani? Kuphenduka H2O. Ngamanye amazwi lo OH has gained a hydrogen eyodwa, and we know by definition that a substance that will gain or receive a proton is what? Is a base. Right. Now, if sibuka NH3, NH3 hamsano NH4. Now, NH3 is a base, NH4 is an acid. Le acid lesoyibiza nge-conjugate acid yale base. So we have that a base having what? A conjugate acid. Now H2O, it is an acid. Ngoba H2O hamsano OH minus, this is a base. So this will be the conjugate base. So sikhuluma ngani? Nge-conjugate acid of a base and a conjugate base of an acid. Those will be what? Ama acid base conjugate. Conjugate acid base pair. We have pairs. Ngoba out two. One acid and one base is occupela one acid and one base. Right? So we have that one. Now we have the first pair is the acid. So if in an acid in a conjugate base, and a base has a conjugate acid, so you cannot find a conjugate base of a base. A conjugate base, yeah, acid. Right. So in this case, it's in an acid, so the conjugate acid of a base. Noma ube conjugate base of an acid. Conjugate base of an acid. So fancy understanding about it. A conjugate base, no conjugate acid. It will also depend what is in a base, no acid engine. Because in terms of nature, beskuluma a strong acid and a strong base, weak acid and a weak base. So each acid will give us what? A conjugate base. Each base is osniga a conjugate acid. Now, if we have a strong base is oskipela a weak conjugate acid. A weak base. Now we are talking about a conjugate base, ye acid, ne conjugate acid of a base. Now, ngoba a conjugate acid ikamuga kwi base. Now, depend on how is the base. If the base is strong, a conjugate acid will be weak. So we say a conjugate base of a weak acid is a strong base. And a conjugate acid of a strong base is a weak acid. So a conjugate, the nature of the conjugate acid or base will always depend nge acid noma base like pumagion. So my sugar kwi strong base uzotola a conjugate acid a weak, like HCl. This one is a strong acid. A conjugate base here, by definition, says that conjugate base, an acid is a proton donor. So masikhuluma nge-conjugate base sivele sisuse lo H wakhona. So masikhipha lo H sesele no Cl minus. This Cl minus, because it's a conjugate of this, then it is a base. But ngoba iqhamuka kwi strong acid, this one will be called what? A weak conjugate base. So this one, it is a conjugate base of this acid. If we have an acid like H2CO3, this is a carbonic acid. I conjugate here, the conjugate of this one. Lana masikhuluma nge-conjugate sikhuluma ngokuthi sisusa hydrogen eyodwa, not like ionization noma complete ionization la sothi khona this acid here is a diprotic acid. Masikhuluma nge-conjugate acid sikhipha i-hydrogen eyodwa. So in that case, i-conjugate base yale acid will be HCO3 minus. HCO3 minus. So this is what? A conjugate base of this acid. But ngoba the acid is a weak acid, this simply means that this conjugate base is what? Is strong, because it's coming from a weak acid. So anything that comes from a weak or strong, it will give us a weak acid or a weak base. It will be what? A conjugate, a strong conjugate base or strong conjugate acid. Right, so those are a few things that you need also to understand. And then besikhuluma nge-ampholyte, because this HCO3 minus, this one can also act as an ampholyte. Ngoba masithatha HCO3 minus, this one can act can have two possibilities. Ngoba inga receive hydrogen, it can get an H plus. In that case, because it will receive, it's acting as what? As a base. My receiver lo H plus is over H2CO3. But it can also lose what? The same, right? City plus H. Then if it can lose a hydrogen, then we remain with what? CO3 2 minus. Now in this case, it acted as an acid. In this one, it acted as a base because it could receive. So any substance that can act as an acid or a base is called what? An ampholyte, right? Or it can be called also an amphiprotic. It's the same word, right? Ngakhuluma nge-ampholyte noma sikhuluma nge-amphiprotic substance. It's definition eyodwa, right? Then when the acids react with a base, when the acid react with a base, the product is always what? A salt and water. A salt and water. Acid base reaction. Acid base reaction. An acid reacting with a base, right? We'll find that if an acid react with a base, then your product is always a salt and water. Salt and H2O as a product. Now, the salt that is produced here will all again depend on the acid, the type of acid, and the type of base that is used. Now, kungenzeka react a strong acid that will react with what? With a strong base. With a strong base. And getting over with strong acid, it will ionize completely. This one, go by it a strong base, it will dissociate completely. So the level of ionization is over ifana from the chemical equation between the strong acid and the strong base. So this one will give us what? A neutral salt. A neutral salt. The salt that is produced there is not acidic or it's not basic. Ngoba ikamuka from a strong acid and a strong base. That what we know is that from the information here, because you have to neutralize an acid with a base, then the salt that is there will always depend on the nature of the acid and the base that is there. What if a reactor is strong acid? This time a reactor is strong acid and a weak base. In that case, because the strong acid is ionizer completely, but weak base will dissociate partially, you'll find that at the end, you'll have more H plus in the solution. Ngoba i-base ayidissociatanga completely. It means kuyashota ngama ions azo-reacta nama ions when we acid. So a solution that you'll get will be what? An acidic solution. Right? You have an acidic salt that will be produced. Then the third situation will be when you react a weak acid that will react with a strong base. A strong base. So what we know is that the strong base will dissociate completely while the weak acid will ionize partially. So in the solution we'll have more base, the ions OH minus, that will be in greater proportion compared to what? To the H plus from the weak acid, because the weak acid did not ionize completely. So this solution here will be what? Will be basic. Right. So that is what we need to, a reaction between an acid and a base. Right. Then the next thing, because we are talking about this reaction, the acid will always tend to neutralize the base, and the base will try to do what? To neutralize the acid. Right. Now, if they neutralize each other, there is a point where we can now understand how to mention or how to indicate whether an acid or a substance is an acid or a substance is a base. Right? We have what we call a pH scale. Talk about a pH scale. A pH scale is a set of numbers ranging from 0 to 14 that will indicate how acidic or basic a substance is. We call it what? A pH scale. A set of numbers, right? Set of numbers ranging from 0 to 14. These numbers will indicate how acidic or basic a substance is. How acidic a substance is. Now, from those numbers, we have we said from 0 to 14. So it is a scale that you have. Then at the center there we have what? 7. If the pH of a substance is 7, then that substance is what? Is neutral. That substance is neutral. Now, what we know in terms of the pH scale, anything in a pH less than 7, that one will be what? An acid. So the pH of an acid always vary from 0 to excuse that. All right. Sorry for that, learners. Now we're saying that the pH of any acid is from 0 to 7. Then any pH that above 7 to 14, that one will be what? Will be a base. So if the pH is 7, then we have what? A neutral substance. Now, by the time we react acid ne base, ma-add acid kwi-base, the acid decrease pH ye-base, and the base will increase pH ye-acid. The tendency to reach what? The neutral point. Ingakho the reaction between an acid and a base ibizwa nge-neutralization reaction. An acid tend to neutralize a base, and a base tend to neutralize an acid. Right, so that is the pH. So when we are reacting an acid and a base, it will always depend ngokuthi you react with a strong acid or a strong base. So the pH does not change in nature a substance, acid. If an acid is a strong acid, normal pH ingaba 0.1 noma ingaba 6.9, still it is what? A strong acid. It's still a strong acid. So when we are talking about a weak acid, asisho ukuthi the weak acid pH yakhona it's always close to 7. Or you can have also a strong acid in a pH that is very close to 7. So the nature of the acid is not determined by what? By the pH that you have. So you have a strong acid to remain strong acid, even if you are increasing or decreasing what? Its pH, but it's still what? A strong acid. Right. What is the next thing we have to look at is looking at the reaction between the acid and the base. Now, maskuluma nge pH scale, there is a substance ezokutshela ukuthi now this substance here is an acid, and there is a substance that will change a color, right? That will have different colors in the presence of different substances. A substance ezoshintsha umbala when it is in presence of acid, normal, when it is in the presence of the base, and that substance is called what? An indicator. It is called an indicator. So an indicator is just that substance that will change the color in the presence of an acid or in the presence of a base. Right, that will be the indicator. So once usebenzisa indicator, the indicator will also go with a certain range in a range pH, right? The range in terms of pH. Njengoba lana stay a strong acid, a reactor, and a strong base, zosinika a neutral substance. Funa indicator in a range lapho 7 ngoba it's a neutral substance. And that kind of indicator sibiza nge bromothymol blue. That one is a bromothymol blue. Ma si reactor is strong acid ne strong base. Nika a bromothymol blue ngoba range pH range e bromothymol blue ilapho 7. When you react a strong acid and a weak base, is solution is acidic. So sidinga indicator in a pH range of less than 7. So sebenzisa a methyl orange. A methyl orange. Sebenzisa a methyl orange ngoba I pH range yakhona it's around 3 and 4, somewhere there below 7. Indicator so sebenzisa masi reactor a weak acid ne strong base, because sidinga a basic solution. So sifuna indicator in a pH range just above what? Above 7. Leyo indicator le ibizwa nge phenolphthalein. It is a phenolphthalein. That is the indicator esosebenzisa masi reactor a weak acid ne a weak acid and a strong base, the phenolphthalein. Right, so you have that one. You are able to choose a correct indicator based on i-acid ne-base or reactant, right? Okay. Asicine lana for today bafundi, so that next week soqhubeka khona lana sesowenza ama-calculations we-pH mese siyabuka futhi i-reaction of acid and base esibiza nge-titration. Lokhu sizokwenza next week, same time, same place. Siyabonga.
Siyathemba nifunde kahle nasithokozela isifundo sethu sanamhlanje. Enisethulelwe ngezilokotho ezinhle iThala libambisene ne-GoDigitalSA Foundation. Thamelani ke futhi esilandelayo ngesikhathi sifanayo. Ningakhohlwa ukumema nabanye abafundi bebanga le-12 ukuze nabo basizakale kulolu hlelo. Uma ninemibuzo noma nifisa ukuxhumana nathi, ningasithinta ngokufaka imibuzo yenu kwinombolo yethu ye-WhatsApp ethi 068 151 1072. Mfundi, ungakhohlwa ukubhala isifundo obuza ngaso ngaphambi kokubhala umbuzo wakho. Angiyiphinde inamba yethu 068 151 1072. Siyabonga.